And I'm going to give the floor to Fuat. So Fuat, I think, has a notebook that he's going to share with us. Yesterday, I think we had a little bit of a pacing problem with Ahmet's lecture. I was expecting him to like code together with you. But right now, what we have is that we're going to give you a pre-made ready notebook on Jupyter, and then you will be able to follow Fuat's lecture in real time. So Fuat, over to you.
Yeah, thank you, Hocam, for your. Is it work?
You are, I think you are pausing. The internet connection is fluctuating.
Yeah, I see. I'm in my room, so I just want 30 seconds.
Okay. The go to a place where Wi-Fi is good.
Now probably my cats will come on the floor, but
it's okay. We love cats.
Hi again.
Hello.
Can you hear me now?
Yes.
But I couldn't hear you. Sorry.
I'm here. I'm here. 1, 2, 3. Can you hear me?
So now I think you can hear me, right?
Yes.
Okay, great. And so welcome to this introductory Python coding course. I just shared the GitHub page. I will define what to do, what you should do to open it in your browser. And in this session, we will cover the fundamentals of programming and focusing on introductory concepts and basic problem solving skills with Python. And our main objective is to enhance your ability to think as a programmer and develop some fundamental programming skills. So through the course, we will be using, I will be using Jupyter Notebook as my programming environment. And you can access the Jupyter Notebook that we will be using for the lessons via GitHub as shared in chat. And the installation process is very straightforward, and there are plenty of resources available online, and you can find relevant links via this notebook. And typically Anaconda is recommended for installation. It's a navigator for Python, the most common one. It's not only Python, but also a few more programming languages like Spider, R, etc. You can just download it and set it up. There are necessary links here. And however, if you have already installed Python in your computer, on your machine, you are using it via another IDE, or you don't want to install it right now, you can just follow the class along using Google Colab. Without Anaconda or Python in your computer, you can just click on this link by Google Colab. So it's an online notebook provided by Google that runs directly in your browser. And it's a convenient platform, especially for shorter tasks. And however, so I think the main problem with this Colab is there are some limitations on the amount of RAM provided for free on this platform. And if your computer is relatively new, it is likely to perform. I think it is better to work in your own computer. It will probably work better than Colab in terms of speed and resources. But in Colab, at least for now, you can just copy the GitHub link that I shared with you. For example, this is GitHub link for the page, relevant page, notebook. Then you can just click here, open notebook, and on this GitHub so you can also open notebook that already downloaded in your computer, or go to GitHub section and just copy the link here, existing GitHub link here. And then Colab will recognize what's going on here. You can just click this one. And then Colab will just open that GitHub page as a notebook. So you can also follow the course on your browser if you want, but I will go on this page. And so if I assume that you already downloaded Jupyter Notebook, but it will take some time if you want to do in the long run. And you can just, there are some multiple ways of opening Jupyter Notebook in your computer. For example, you can just open Anaconda Navigator. I assume you already downloaded it. And there will be a navigator here. You can just click on it. It will take some time, but you can also get access some other platforms, other programming languages via this navigator. But I always prefer to use Prompter. I think so it enables much more operations. For example, so if you want to use different environments, I am in the base environment now, right now. Here you see the base, and the environment basically refers to a hardware platform and the operating system that is used. If there are contradictions between different packages, sometimes we might use different environments, create new environments in our computer. And for example, if you want to use different versions of the same program, for example, if you want to use the most recent version of Python and already an old version, you can create two different environments into your computer. And here, via the prompter, you can just activate another environment. For example, I will just activate another environment that I built for geospatial analysis. Then in that environment, here now I am in geo environments that I previously created. And here in this environment, I can just open a Jupyter notebook, for example, here. And then it will be opened in another environment, but just forget this for now. This is just an option, but so you see here, yes, it opened any notebook in a different environment in my computer. But for now, I will use the base environment. So that's the basic benefit of using prompter instead of navigator for Anaconda, I mean. And so in Jupyter Notebook, we have, so here, sequential cells here. So you see that there are different cells, markdowns, and codes. For example, this whole thing already created in a single cell, and it is in textual format. And we can just run different cells separately from each other in a Python Jupyter notebook. And so in a cell, for example, so if this cell is defined as a code, you see here, and I can just turn it to a markdown, then it's just a textual thing. There is nothing to run here, but it is already defined as a code. And this sign, if you see these brackets, then it is already described as a code cell. And so just below of your code cells, you may see some outputs. If I run a code, then it will extract the output just below of that cell. However, it depends on whether you requested an output in your code. You may convert those cells to markdowns, which only present textual and image-based contents. And in this left side, you can navigate yourself. And this also determines the active working directory. So here you can just change your working directory, go from desktop and choose another one. We are here now. And there are File, edit, view, and these sections here. So in this one, you can add empty cells just above or below a already selected cell. You can just copy them and you can move them below or above. And there are shortcuts. Shortcuts are life-saving while using Python Jupyter Notebook. I strongly recommend you to learn those. For example, if you want to add just a shortcut above, you can click on A, and here I have an empty cell. Or if you click on B, it adds an empty cell just below of the selected cell. Or if you want to delete it, just double click on D, for example. Sorry, not in the cell, but while the cell is selected from the external page. So here you can just double D, by double D, you can just delete the cell. And kernel might be important here to some extent. Kernel means the core component of an operating system. When you open a notebook and you start a kernel directly, automatically, and it keeps imported packages and defined variables, objects in the memory while you are working. It's a temporary environment. It's a temporary operating system, memory. If you want to restart your Jupyter, for example, it is enough to restart your kernel here. And there are already also shortcuts for those operations. And so you may, while restarting a kernel, you may delete existing outputs or command the program to run all cells together. So from the beginning, let's run all cells, and you may want to clear outputs, etc. And also sometimes if your notebook collapsed, you may just want to interrupt the kernel, and this is already operating system on your browser. What about import? So just like other programming languages, in Python we call libraries to work with them. And if you want to run log function, for example, here, it belongs to the math library. And first thing you should do is to import this math library. For example, if I run this one, this cell, what's going to happen? Let's see. So it reports that name math is not defined. Python doesn't recognize math because nothing like that important. And after importing math, I can now use the function here. It is ordinary, usual logarithmic function, just belong to math. And this dot works to go from in math library, use this function or this method. So dot in Python language is being in that sense. And here you see, I can call just pi number and try to calculate a cosine function for this pi number. Let's see what's going to happen. It is -1. If you are familiar with trigonometry, this might be familiar for you. And we can also just prefer to call these libraries with some acronyms. For example, I don't want to write, if your library's name is very long, then you may just use a shortened version of it. You can just call this library as another name, whatever you want. Let's try to do that. Yes. And also, you may want to go for a very specific function in a library. For example, we have a statistics library in Python, and I just want to call mean function in that library. So from statistics, I directly call import mean and ignore the rest functions in that library. So in this function, in Python, we just use parentheses to put objects in functions, Here we have a list including 4 values. So in this list, we will just take the mean of this list. Here you see. Yeah, and there are libraries and packages, and so there are 2 steps of working with a library in Python. First, that library should be installed into your computer, and more specifically the active environments. For this, we use pip install. There are some dependency modules, Anaconda, they are already downloaded. But for the rest, you should first, in the first place, in the first use, you should first download these libraries into your computer, and not directly in computer, but the environment, the active environment. Then you can import those libraries into your kernel. For example, for pandas, it is already installed with Anaconda. However, if you are interested in NLP and want to import an NLTK, you should first pip install this library. And in the second stage, you have to call it just active kernel. And there are some optional materials here. You may take a look at those. For example, in my courses, I use this Wonderplus book. It is an excellent book for machine learning tasks. And there are some additional resources and links. You can just click on those. By the way, I just combined 2 different notebooks while preparing this material, and these notebooks are prepared under the scope of Social Comquant project, different workshops of the project, and there are you can see some credits for a different person through the notebook. And after this introduction, now we are going to go over 9 subtitles here in Python, or let's say as much as possible we can cover. And there will be some exercises in this session, but I would like to leave them all to you as ungraded assignments or something like that. And you can also find solutions in the GitHub page. Here I have the other one. You can work on your own, and then you may just check the answers. You may try to find your own way. But it is looking the answers good, but I think it is better for you to try to solve on your own. Learning a new programming language entirely depends on your own performance to practice what you learn, and these exercises in that sense might help you. And so what about Python? I don't want to glorify Python. There are too many advantages and disadvantages as always, and I don't want to glorify any of the programming languages, but I think the key point, in my opinion, so which program your colleagues use, if all statistical tools are written as R packages and you are basically a statistician, then using Python makes no sense. But best advantage of Python is therefore, at least nowadays, it is being used by most of programmers from infinitely many different fields. But still, compared to our older programming part, is much more powerful. Statistical packages, or at least frequentist statistics, in sense of frequentist statistics, they are quite rare in Python compared to R. But the best way is to be able to use both, I think, at least at a basic level. So here, the topics, printing the screen, it means outputting text or data. Variables, they are containers for storing and manipulating data values in computer memory. Lists, they are ordered collections of items that can be modified and accessed using indexing. And strings are sequences of characters used to represent textual data, usually. Dictionaries are unordered collections of pairs, key value pairs, which allow efficient lookup and retrieval of data. And there will be operators, symbols, and keywords used to perform operations on data, such as arithmetic or comparison or logical operations. And if statements and loops, these are conditional statements, and in every programming language you may find those. These are repetitive structures used to control the flow of the program execution based on specific conditions. And functions are blocks of reusable code that perform specific tasks, all predefined tasks these are, and they can be called or invoked from other parts of the program. And files, so handling and manipulating data stored in external files, such as reading from or writing to files. So in every programming languages, probably you are already familiar. If you know at least one programming language, you learn something like printing or printf, something like that. And this function basically works to extract some outputs. And the basic, the mostly used phrase is hello world, right? In quotation mark, we have the string here, and in parentheses, the input of function we have, and print function just will extract already so read input. And in this function, however, we have some other default operations. So for example, so if you use command before going default operation, let me show one more thing. Here in Python language, we add comments after hashtags. In other languages, there are some stars or etc. But in Python, we have hashtags to add comments, and the Python will ignore all these lines if you use this hashtag, or you can add your hashtag just at the end of your running function, something like that. The default options here, the default arguments in Python functions are separating. I just included two of those, separator and ending arguments. So for example, here we have some default things. Let me just write down here. There is this kind of invisible operator, and reverse /n means go for next line. And after print function, always Python goes the next line. And separator means if I have multiple objects here, just separate them by using one single space. So this will exactly give the same output. But if I change, for example, so if I use different prints and separators, then this condition will change. For example, I am changing this AND argument with 3 next line objects, and I have 3 different print functions here, 2 different, sorry. And here we see 3 different lines. This is what this AND argument did. And here we have multiple objects in print function and use the default separator. And if I change this one, for example, let's put it here an exclamation mark, then this different objects just separated from each other with an exclamation mark. And if I just print different print functions, then there will be a default reverse /n object. And if I change, so this will be just exactly give the this will give the same output. And if I change this one, then the output will change. And I can also modify this AND argument for different print functions. So in this cell, for example, this print function will have one space as an ending argument and one exclamation mark for the second print function. and the output will be just like that. What about variables? Variables serve as designated memory spaces used for storing and retrieving information. And they allow us to temporarily store a value in our computer's memory for future use. So here, how to define variables in Python language. So in the right-hand side, we have the value that we want to assign. And the left-hand side, we have variable name. In Python, equal sign does this assignment job. It was something like that in R, as far as I remember. I think it was like that. And this equal sign works to assign this name with this value. And this is an integer, for example. This is a float, and this is a string. And now I have three different variables. It is totally different than mathematical sign. So this doesn't refer to a conditionality. In math, when we use equal sign, we refer to a condition, right? But in Python, we are just doing an assignment. If you want to use to refer a condition, then you should use double equals. And we will see while working on if statements, you will see what I mean by equal signs. So this is how we define our variables in Python. And there are some standard variable classes in Python, just like other programming languages. So we have integers, floats, and strings. And here you see we also have Boolean operators. So Boolean operators, so Boolean values can just have two values, 1 and 0 refers respectively true and false. So they can just they are just able to have true values, which basically we use while calculating the outputs of conditionalities. So we will see further some Boolean operators below in the logical operations. So here we have, so let's name our variables, right? Here there is an example. Let's define x as 10 and y as 12.5. And there is this operation, this is multiplication operation, x multiplied by y equals z. So I just run a mathematical operation here and print z. Then this will be like that, right? It's a basic math. And in the second example, I first defined number of students in a class, let's say, and number of teachers. And to calculate how many people in the class, I just add them together and print this sum variable. This is 42. And this section will ask you which one is better. So if I want to turn back this point later, naming my variables as x, y, z is not an efficient way because it is hard to remember what's going on here. And I think this kind of naming might be better for you to remember what's going on here in this cell. This was an issue. And there are, so another reminder here. So for example, using lowercase l or uppercase O or uppercase I, for example, is not efficient. So it might confuse yourself. The key point with O, it pretty looks like 0. So avoiding these might be helpful for you. And also uppercase and lowercase, there is this sensitivity in Python, which was another important point. So just do not forget which, so these are separate, referring separate variables in your working kernel. So there are some reserved names in Python. We do not use these names in our as our variables because they are used for other things. For example, if I want to create a for loop, then I shouldn't use for, because Python will just recognize this already existed function for this, or operation for this. So I shouldn't use these names for my variables. There are some exercises. We can go over those together. And let's define some variables. I have a string value here. Let's say love Python, and I have a float value, an integer value. So I first, I can change, if you want, you can change these codes on your own. But here, let's keep them together. And in an if statement here, we can just test whether my string equals already defined as love Python or not. For if statements, we use colon here at the end of this if, this line started with if, and this refers to conditionality, and it says if my string variable equals this string colon, then do the operations. So here we have an indentation, and after that the program will just give me the output, which is defined here. And here there is another tricky thing. If I use percentage sign here and use SF or I, then this will directly goes the variable, the value defined after this percentage. So let's run this cell. Yes, this will be this will give true as an output. So the already defined print function will work. And in this print function, this after percentage s value will refer this value, and directly this print function will take this number, this value, sorry, this string as an output. So here we have another example. In the first place, I defined my name. So it is a string. And I want to print, let's talk about these people. So it's a string, and if I change Fuat, directly this object will change. And in the second hand, I have my height. I also define this one, but this time it is float. So the difference between floats, and maybe you are already familiar, but it is important to remind, the difference between floats and integer is floats have decimals, more than one decimals, at least one decimals after this dot. So my height will probably be something like float, and here's my weight. So let's run this code, and here you see Python will extract. Let's talk about Fuat. This string just comes from this value variable here, and there is one empty line because I just changed the default option from one next line operator to two next line operator. And in the second line, I have my height, and in the last one, I have my weight. You can just modify this number, and the output will change. So in Python, we also have lists, just like other programming languages again. So lists contain ordered objects, and everything can be a value under the list. So here we define just an empty list. Brackets directly refer lists in Python. If you use brackets, if you want to define a list, you should use these brackets. And this is an empty list. This is a list of integers. And here I have a list of strings. And also I can have combined. So let's run this one first and see. By the way, if you just wanna take a quick output, you can just click on you can just write down your the name of your variable and call it without using print. This also extracts, but it might confuse if you want to obtain more than one output. And let's add another value here is in an integer form and also a float form. And here I have the values. By the way, if I didn't tell, let me tell now as a shortcut. So while running this cell, you can just click on, so you can go this run option here. And for example, you can just click on this button. However, here you see there are shortcuts. If you click on Shift Enter, it will just run the cell and will go the next cell. So while using on your own, it might be good to remember to save some time. There are some operations on lists. Here we have a list of prime numbers. Let's define first this list, and then let's check its type. Type function in Python just extracts you the type of the class of that object. So we expect to see list here, right? So it is a list. Primes object now is defined as a list. What is the length of primes? What will length refer here? It will refer the number of objects in this list. Now here it is 6. So we have 6 values, 6 different objects in that list. So I can also call specific objects just by typing the index of that objects. And different than R, I think this is one of important difference between Python and R. The index numbers in Python starts with 0 instead of 1. So it is one of important differences between these two programming languages. So if I just call 0th indexed number, it will give me the first value in that list. Or let's call the 5th indexed value. It will give the value in the last place, but this is 6th theoretically, right? But in Python index, it is 5th. It is important to remember again, another important point. And I can also modify elements. That's why we use lists. And here you see the 5th indexed value is defined as 13. Let me put it here, the previous version. Here it was like that. But then after I define 5th element, 5th indexed element as 13, then it will become like that. I just change this value to 13. So I can also append some new values to my list. This is what append method does. So after that, I can just add append, and in the function, I can just include any specific value. And then now I have one more element here. And to delete that element, I can just use this delete option, delete operation here. And here I need to specify the index again. Now it turns back. To copy lists, there are, so it is another important point in Python. I'm not sure about the other languages, but in Python, if you just write your variable name, or if you just assign a list to another name, it doesn't change the actual position of your first list. Let's see what's going to happen if I just append another value to two new names of this variable, this list. So in Prime's copy, I appended a new value right here. Here 19, but I didn't change anything in primes, but it also changed because I didn't create a new list here. I just have now two names for the same list in Python. To do it in a proper way, I need to copy the list and write it down in another list. This is how properly we can copy lists in Python. So in this framework, let's run again. Here, the copied version, now it's a new list. We have one more variable here, value here, but here we don't. And there are some other methods with lists: insert, extend, index, remove, sort, reverse, pop. So you may just imagine what they are doing. For example, if you use reverse, it will just reverse the order of values in the list. Or if you use insert, you can just insert a specific value, specific object to a specific index. Let's see it here. So we have a list. It contains red, blue, yellow. And let's index black to a specific position in that list. I will use insert method here. So I have black as a new value. And this is where I specify the index of this new value. So add list here. So add this element to list. And now I have another list including 4 elements. And also I can use extend methods, which will just work like append, but now I can just use more than one objects and widen the existing length of my predefined list. And there are some exercises here. I'm just skipping those for now, but you may work on it on your own. So what about strings in Python? We have strings as well, but so to define those strings, we just use quotation marks here in Python. And let's define A as we love Python string with an exclamation mark. And then let's split that string into 3 different parts just by using spaces. So in this split function, whatever I specify, this method will split the string using those specification. We love and Python. It extracted 3 different words and put them in a list. So here I have A, we love Python again, and B, Python loves us. What if I just add them together? How Python is gonna recognize? Will it give me some errors because they are not numbers? You are not allowed to add them together. No, it works. It just add them together as strings. But what if there will be a number here? There would be. Then it will give error. So if both of them are strings, then Python says, yes, I can add them together, but not mathematically. So now it's C. I defined C here. What about calculating the length of strings? It extracted a number here. So it is the length of characters, right? And in Python, strings are, sometimes we can treat strings as lists. And here we see a slicing and indexing part. So for variable a, we love Python, 3 different words and 15 characters. And all of them, just like a list, are indexed in a specific position. For example, in this list, if I call 14th indexed value in the list of A, then it will print the exclamation mark here. There are spaces here, you see. These are spaces. And they also have a place in the list. And we also have reverse indexes here. So reverse indexes are very important while working with really huge, large strings, because going to the end of that long sentence, calculating the total length might be cumbersome. And I may want to just go the last verse or last characters. That's why we are using these negative numbers while indexing. So to print, for example, in a specific string, substring in a string, I can just use slicing. So to cover this keyword here, I can just specify the index of first character and the index of last character. Just try to extract log here. Yeah. Here it was a list, and I just sliced from 3 to 7, and it extracted this word, log. And note that the last one is not included in that slicing operation. So if I just want to have 4 characters, I need to add 4 to 3, but the last one will not be covered. If I want to slice all characters located after the third one, then just do not add anything here and leave there empty. And then it will be sliced like that. So it will go until the end of this list. And if I don't specify anything in the first place, then it will start from the beginning of the list and up until the specified number. And I can also use this slicing by specifying the number of steps. So I want to go from 0th to 14th by jumping 3 characters. And if I don't specify anything for the first 2 columns here, and these will be considered as default options, the first and the last one, and this will give the same output. So there are this relationship between strings and lists in Python. So what about dictionaries? I think dictionaries are quite important. So in earlier sections, we explored the capabilities of Python lists and some other operations and saw their strengths. Now let's delve into another data type in Python known as dictionary. Dictionaries play a really important role while making, while creating our own data sets. Most of databases use this structure, dictionary structure, and depends on their background, they are depending on this framework. In dictionaries, so to define dictionaries, we use curly braces, curly brackets, and I think in Turkish it is called süslü parantez. And so to define a dictionary, to describe a dictionary, we need to consider some pairs, right? So in the first place, we need to define key values and keys and values. So after the curly braces, in the first thing, as the first thing we should do to define a key, and using colon, what does this key refers as a value? Comma, let's go for the next pair. This is how it works, and at the end we should just close the dictionary. Here there is an example. Let's define a dictionary called movie. This is how we define dictionary with curly braces. And here our key values, here we have the name. This is the name of movie, the director, the name of director, and the year. Which year this movie published. So I can just call specific methods here for dictionaries. For example, so let me first define this dictionary, run the cell, and I can just get access all key values in a dictionary just by calling keys as a method. And I can call all key value pairs just by calling the items as the methods. So here, all the key values in my dictionary, name, directory, and year, these are key values, keys, not values. And here, the items which are shared as tuples. In few minutes later, we will see what are tuples. So there are pairs, I mean, name and the correspondence. And there are some other exercises here, and there are some specific methods while working with dictionaries here. You may refer those while trying to solve exercises on your own. And there are sets and tuples in Python, different types of data. Sets are sets resembling dictionaries and tuples resembling lists, but in a very different sense. In sets, for example, we have elements which are unordered. There is no order in sets, and all set elements are unique. Duplicate elements are not allowed. You can't use multiple times for the same element. And in tuples, the order is very important, and we never can change the elements after defining the tuple. Let's start with sets. Here I have a list of integers and define them as a set in this function. This function basically works to define sets and assign this value into sample sets object. What is type of sample set object? It is a set. So here I have my list. Now I defined a list here, but just try to convert that list to a set here. Let's see what's going to happen. So yes, this was a list, but I changed it to a set, and now it deleted all duplicates in that list. So there was 7 here, but in the set, we only have one single unique 7 value. So what about strings? So let's convert this string list and set separately and try to see what's going to happen. So in the list version, we have all the characters here, but in the sets version here, we only have unique values. So if you are interested in working with textual data, it is better for you to use lists instead of sets, right? Because characters are meaningful in the order. And for tuples, so this order is very important, and you can't delete these order, you can modify those. So here we have a tuple, here we have another tuple, there are duplicates here, you see. This doesn't spoil tuples, and the length of tuple is 3 here, we see. There are operators here, or we can Akın hocam, should we make a break, 5 or 10 minutes?
Sure, because you should take a break, I think, for 10 to 15. How much do you prefer?
10 is enough
Okay, so let's...
for me, but maybe...
Yeah, it's up to you. It's up to you. You should take a break, just like rest a little bit, rest your voice. How much is good?
Yeah, 10 is enough.
10 is enough. Then in terms of Istanbul time, let's come back here at 8:11. People from other parts of the world, just 10 minutes later, will be here again. I'm pausing the recording. We're going to continue after 10 minutes.
Let's move on with operators. So in Python, we have classical arithmetic operators and some logical and comparison operators here. So the operands here are, so if I want to add some different integers or floats, and I can just use this plus sign, I can subtract and multiply by using star, and this slash works as symbolizing division. And there is this power calculation, a to power 2 a square, which means, and here I have as a, so percentage sign means the remainder of division of left hand operand to right hand operand, and here I have floor division and divides and rounds down to nearest whole number. Here we have an example. So in this operation, I divide floor division. So in the left hand side, I have x, and so right hand side, I have y. This division, this whole number, if I multiply this number with y and add just remainder, it will give the same number with x, right? So what will be the exact output? It will be 20. If I change this one to 10, it will extract the 10. So this is a basic math. So what about logical operators? Here I have two conditions, true and false, and we have three operators. So it's a universal thing. And if I use not, it just reverses the logical state. So if A is true, for example, not A will exactly be equal to false. And operator combine two different Boolean conditions together, and only if both side operands are true, it will extract true, A and B true. If A and B true, then I can say easily that A and B are separately true, and or just like another, just like logical operations, all other logical operations. So for example, A or B will extract false only if both A and B are equal false, otherwise it will extract true. And what about comparison operators? So these will be symbolized like that. This is how in Python syntax we use comparison operators: less than, less or equal, greater than, greater or equal, equal. We use double equals here to refer this equal conditionality in math. And not equal we have with an exclamation mark and equal sign. So, for instance, here, let's define A, B, and C. And here I have A6, B7, and C42. And here you see different print functions. And for each, there are some conditionalities. So this refers a conditionality. This is not an assignment. So I'm not assigning 6 into A here. I'm just testing whether A equals 6 or not. For example, this should be true, right? Let's run the cell and see what's going to happen here. So in the first place, the first print refers true, and the second one refers false because A is not equal. 7. If I just turn this not equal, then this will turn to true right here. And here there are two conditions. This is true, and this is also true. Then true and true will extract true. And here I have or, for example, A equals to 7 and B equals to 6. Both are false. Then this 7th number print will just extract a false value. Here we see. What about if statements? So if statements in Python allows us to control the flow of our program based on certain conditions, and we can use if statements to perform actions only when specific conditions are met, and making your code more flexible and responsible. For example, here we define an R value. So I assign 2.4 to R. And in the first if statement, here I have if in the beginning of my line. And at the end, I need to have a colon here. And there is a condition here. If this condition is true, then the program will go in the next line and will just run this line and assign one into event variable. And if it is wrong, this condition is not satisfied, then this will go this elif line. Elif means else if. So if the first condition is not true, but the second condition is true, go the second line, this line, and assign 2 into event, and both are false, then go for the next line, and this should do this operations, and assign 0 into event variable. So what's gonna happen? Event is 2, right? Because the second condition is satisfied, only this one is true. If I change to 4, for example, then the first condition will be satisfied and the rest will not be satisfied. So this is a generic explanation of if statements. What about loops? And loops such as for and while loops in Python, so they enable us to repeatedly execute a block of code, and they are useful when we want to perform a certain action multiple times, more than one times, or iterate over and over a sequential element, for example. And loops allow us to automate some repetitive tasks and process data efficiently in our program. And we generally use for loops in Python, in other languages as well, because while loops might cause some infinitely endless loops, but in for loops, the risk is lower. That's why generally we use fors, but also you may want to learn how while loops works. Here we define a list, and in this for loop, we will just iterate I values through these lists, through the values of this list. So in the first loop, in the first iteration, I will be 1 because the first element of the list is 1, and we'll print I, and then I will become 2 in the second iteration, and this will print 2. So let's run 1, 2, 3. We have 3 print operations here. So we just run this print function 3 times, right? And here another loop we have. This range statement is a great list maker, in an easy list maker. Here there are some specifications here. It starts from the first value, goes up until the next value, the second value, and these are the steps. So how many jump we will have? So I will just iterate through this list. So for each time, I just want to extract the square of I. Here, let's see what's going to happen. So square of 1 is 1, square of 2 is 4. So for every time when I was 1, it will just extract 1 here. And also I wanted to just extract the actual number, the I number, and it will goes until 10. And the last number is not covered again. What if I just use this in this form? So then range function thinks that if I just include one simple value here, then range have some default values. It will start from the first value, goes up until this value is specified here, and the default option for step is 1 again. And this will run the same code directly, but there is one difference here. I just started this from 0, but again, in Python, the default starting point is 0 rather than 1, which is an important difference from R. So here we have another list. And in this list, now I just want to iterate over the index of this list. So let's first calculate the length of this list. This will be 6 here. So this is range 6 then. So I will have I values here that goes from 0 to 6. 0 to, not 0, 0 to 5. Because I will have 6 values. And in this for loop, in each step, I just want to go for the index number here. For example, in the first iteration, I will just go the 0th index of this list and will define j as this number, and then we'll calculate the square of x and report that. So the first number is 0, and let's say the third number is 5 here, and j in the third iteration will be 5, will be assigned as 5, and the output will be like that. And there are some exercises here. You can just find the solutions in the other page, and you can just try to build these on your own, the solutions on your own. By the way, there are multiple ways to solve these questions, and the best way, I think, is to find your own way. So writing code is something like that. And this is an example of while loop. In while loops, we just define as a condition the getting out condition. So if this condition satisfied, go over the iterations, but if this condition is not satisfied, then just drop the loop. This is how while loop works. For example, here we defined I as 0, then the condition is defined as if I less than 5. So in the loop, we increase I by 1 and just print 10 times I. So in the fifth loop, I will become 5, and then while loop will end. But if I don't specify this, probably the program will break down because there will be infinitely many values, right? Because this condition never being satisfied. I will not change, I will not increase, and there will be an endless loop here. But in this condition, we have these outputs. So we can also ask users to give some inputs in our code. So for example, I can just ask a question to user, then we can specify an input here. So ask input to user, and then take this input, convert it to a float. This is a floating function, and assign this value into age. Do the same for height and weight, and then just report the general physical features of user. So in the first place, it will ask how old are you, and then input comes. Let's say 23. And how tall are you? Let's say something like that. And how much do you wait? And this. So then it will just report the physical features. And here you see again, if I use in my reports here, %f values, and then these will directly refer the values after defined after the percentage here. What about functions? Functions in Python basically allows us to group a set of related codes together and give them a name, basically. They provide a way to compile our codes and make it reusable. And by defining functions, we can define a specific functionality or tasks, which then can be called again and executed whenever we want or whenever we need. And functions help us to organize our codes and improving readability of codes and promoting so our code reusability. And here a greeting function, the input of this function. So function starts with def. Def means in Python, define a function. And after that, we have the name of function. In parentheses, we have the input, the name of inputs, and again, we have colons here. There is this indentation, and just return the output. So let's add hello and my name with a simple space here. So if the input is Fuat, then this cell will be, will give me an output like that, hello Fuat. So in a function, we have a header here. So this is function's header. And we have an explanation here, which is called docstring. So it is very important to remember what was our function is doing. So maybe in few years later, we might want to turn back our previous functions. And it is very important to remember. So these are self-explanatory notes, and Python will not read these lines, if we use 3 quotation marks. And there is this body of function here, whatever we want to do with this input, and return. This is the general structure of all functions in Python. So, for example, if I just take Fuat as input, then hello lovely Fuat, and go the next line after a dot, and let's add another one, you are the best, then it will give me something like that. So let's make an example here. So it asks us to write a function which takes 2 inputs A and B and return the sum of A and B. So I can just take more than 1 inputs in functions, and let's name this function as sum 2 numbers and the input as A and B. So let me write here an explanation for myself and return the sum of A and B. And this is 8, right? So the inputs here defined and print the output, which is 8. So this is the end of my part, because I think we, so if you want to see, if you want to go over these files options, you may go on your own, but I don't have any exercise for files. You can consider this section as a bonus for you. And for the exercises, again, as I said, there are these answers, solutions. These are my solutions, but you may create your own. And yes, that's all I have. If you have any question, we can maybe go over those, or you want to add anything.
So this was a comprehensive overview of the most fundamental operations and file types in not just in Python ecosystem, but I think in computer science and data science in general, regardless of which platform you are using. Ahmet did something similar yesterday. He went over different forms of operations, different forms of data. So it's actually very useful to have all of these very fundamental and basic functions in one single place. I find this very valuable myself. All of my courses, I teach these things, but I think having them at the same place is very, very good for me as well. So I really benefited from it. So again, for those of you who perhaps could not follow the whole thing, or maybe you got cut off from at some point, feel free to tonight, if you have time. If you don't, we will have a series of lectures tomorrow and the day after. You can also collect the codes for those days, and then in the holiday part, you can just go back and then do all of these codes from the beginning, whichever way fits with your schedule. So I think what we have tomorrow, let me see, we are going to have both Ahmet and Fuat together, and they are going to basically do introductory text analysis and introductory natural language processing in R and Python, because I think it may be confusing for some of you, especially if you are only familiar with one programming language, to get bombarded with content from both platforms. But as I think Ahmet said today, it's useful to know both and Excel as well, because you can't know which one would be useful for this part. You would be perfect with Python, but maybe you were recruited by a lab which uses R. So you have to convert most of your workflow in a way that can be interpretable by R people. And the same is true. Maybe you're very good with R, but then the lab you're working with uses Python. So you have to, switch. So familiarity with both programming languages is very, very important, which is why we are, pushing along two axes. And tomorrow we will do text analysis with R and Python as well. And then the day after, we are going to do, so right now we have a debate whether we should teach scraping in R or Python, or both Python and R, but maybe we may not have that much time to teach scraping in both languages. So one option is to do some beginner scraping with one platform and then move on to more intermediate with the other platform. So we're going to discuss how we're going to do it later on. Then Sunday, nothing. You can basically go over and practice these things on Sunday as well. Since the Summer Institute is very intense, we are promising you high quality education, but we're not promising you comfort. Comfort is not something that you're going to have. So on Sunday, technically it's break, but don't use it as a break. I would suggest, returning back and doing these exercises on Sunday. Then Monday, we are going to have Uzay Çetin Hoca from Galatasaray University. He's going to do data cleaning, wrangling, and manipulation focus with just Python. These are very useful skills. And on Tuesday, 27th of June, we are going to do a data visualization specialization in R. We're going to have a ggplot session on Tuesday. We're going to focus solely on our ggplot ecosystem, because even though you have plenty of visualization options in Python ecosystem as well, I think some Python people also prefer ggplot, both the syntax and how beautiful visualizations it produces. So there is a ggplot package in Python as well. It's very popular. And then I'm going to leave you alone beginning 28th of June until we start these sessions. So we take boot camps very seriously because it gives you some kind of expectation in terms of what we're going to do in the actual Summer Institute event. And even people like me, like I teach this every single year, these refreshers are so helpful for me as well. One, I understand whether my codes and my knowledge is up to date because younger people like Fuat or Ahmet, they often know more about the recent stuff. So I always check my knowledge in terms of whether I know, whether I'm old, whether I'm obsolete, or whether I actually know all the new stuff that is happening. So just having all of those basic functions in the same place is so useful. So let me look at chat. Can we make a poll for now? Poll for what? Whether R or Python to use for tomorrow's session. No, I think that option is for us to decide. So we're going to decide among ourselves, Fuat, Ahmet. It depends on the availability and what codes they have. So it's not a poll thing. So we're going to just decide which one we have in terms of content, what content we have. But practically, we are going to aim towards using both tomorrow. If we can't, then we will do R one day and then find another section to do Python, but we have to do both. I think that's the most useful thing. So any questions about today's session? Because as far as the logistics are concerned, you can always send an email and we can clarify, your arrivals, what we're going to do this day, that day, and the other day. But if you have any questions to Fuat specifically in terms of today's content, please feel free to ask either via chat or you can raise a hand and just charge ahead with your question. I think people are going to start asking questions when they go back to the code, start working on the code, and then run into problems when they are on their own time working with the code. That is always the best way to learn coding, like on your own time. There is like a set curriculum of code. You start working on it, you type, you get a result, then you go to the quizzes or the exercises where you have your first trouble or first problem. And then that's, I think, where people have the most questions. So I'm anticipating a lot of questions in the Bayram as well. If you're on holiday, I can just answer people's questions. So yeah, it's fine either way.
Before ending the session, can I just show one last point? Important. Let me just share my screen again. And this was so if you want to copy this file into your own drive, so this was Google Colab page that you just copied GitHub link. And here, if you click on copy to drive, and if you signed in before, then it will just copy this page to your own drive, Google Drive. So you may also consider to use this click.
Yes, it means that it is basically you saving that worksheet to your own Google Drive, meaning you're just like taking it into your own. So if you change anything in the main term, because I don't use Colab, when you change the main thing, does it also change in people's drive or no?
I don't think so, because this is a GitHub page. I don't think Google can have an access to change that GitHub page.
Okay.
But I think it might be better for the future use.
Yes, yes. In case something happens to the main text, you can just save that workbook to your own Google page. So again, we are going to be bombarding you with a lot of content, most of which you will feel overwhelmed, and you're going to feel the need to revisit them in the future. So for that to happen, take very good notes in terms of what content you were exposed to, where are the codes, how you're going to access the code later on, if you need a data set that you need an access to, where is that data set? Because again, like we do these lectures, but some of them have to go very fast for us to be able to cover a lot of ground in a recorded file so that you can also watch the recording later on. So we're not stopping or waiting for a lot of time. We're just like going. And then for you to be able to revisit all of those, you need to take very, very good notes in terms of where you're going to find the code, where is the code, where is the data, have them structured in your Google Drive or, or on your Word documents or anywhere else. So Murat Cerit has raised a hand. Hello, Murat.
Hello, Hocam. Sorry for disruption. Just a small question. Did I get right that Fuat Hoca has said that we can copy and paste from the GitHub to Colab, or did you have already shared the Colab link that I cannot see?
We shared the Colab link. Let me so there's a GitHub page. Let me.
I just copied chat again.
Oh, sorry.
So
this is the one.
I just showed in Google Colab, you can just using that path open this GitHub page in Colab in a browser in a Jupyter Notebook. So Colab has this option.
Can you show it again?
And after, yeah, I can show it again. Let me share my screen again. So let's turn this off. And here we have Google Colab link. You can just find, or you can just write it down on your browser. So here, colabresearchgoogle.com.
Okay, I get it now. Okay, thank you.
Yes. So colab.research.google.com, when it opens up, you can go.
And in open notebook session here, go GitHub session, GitHub parts, and you can just copy the link here, the page of GitHub link. Then this will exactly open this page in your own browser.
Yes.
Let me, okay, it opens. And then you can copy it to your own drive. I didn't sign in right now, but it will just open another tab here. And you will see that the name will be copy of Introduction to Python, and you can rename it and use on your own drive.
Yes, and that's very useful. Some of our other lecturers will probably also share their Python code with Colab as well. So this is a useful knowledge for everyone, I think. Because some people, for example, I like to go, for example, very slow. Like in my lectures, we all code at the same pace, but it means that I have to cover a smaller amount of content. because I want to make sure that people are typing exactly what I'm typing. And then I go ask them, did you type this? And then until I'm very sure that they're typing exactly what I'm typing, then I continue. But some other people, they share the link and everything. So how can we get the recorded video? YouTube is processing yesterday's video still. We are going to upload all of those into Summer School Istanbul YouTube page. I will send you the links of the videos along with links to the sample codes. So don't worry, you're going to get the links for the recordings as well. Hoping today. YouTube is still processing yesterday's video. I don't know why. I wonder if Ahmet did something wrong with the algorithm and they detected a different strange image and then they're still like moderating content. I don't know, but you will have these very soon. So, okay, let's close it up. Let me stop recording.